Welcome to Spring Lib.
We know that F net, or the net force, equals to minus of K effective into X. And the time period T equals to 2 pi root of M upon K effective. So if the elongations of the spring are X1 and X2, then they must satisfy X1 plus X2 to be equal to the 0.200 meter. Now when we consider the net force at equilibrium, that is F net at equilibrium, that should be equal to 0. So we get K1x1 equal to K2x2 because the net force should be 0. And one spring, the one with K1 equal to 2.00 Newton per meter, must be stretched 3 times than with K2 equal to 600 Newton per meter, because this is 2 and this is 6. So it should be, the spring with K1 should be stretched 3 times with respect to this. Now the sum of the elongations. Sum of elongations is equals to 0.200 meter. And therefore what happens? One spring stretches 0.150 meter and the other stretches 0.050 meter. Why, you know? Because one should be 3 times more than this. 3x. 3 times. Therefore, the equilibrium length would be, one is 0.350 meter and the other one is 0.250 meter. So these are the equilibrium lengths. So when we move to the second part, or the B part of it, we know that when the block is displaced at a distance x to the right, the net force of the block is minus K1 x1 plus x plus K2 x2 minus x, which is equals to minus of K1 x1 minus K2 x2 minus K1 plus K2 into x. This is the net force. So from the result of part A, the term in the square brackets is 0. So this becomes 0. Hence, the net force comes down to, so what happens? So F net will be equal to minus of K1 plus K2 into x. So the effective spring constant, that is K effective, equal to K1 plus K2. And the period of vibration, is given by the formula 2 pi root of M upon K effective, that is 0.100 kg upon 8.00 Newton per meter, and that is equals to 0.702 seconds. So this is the time taken.